Good morning, good afternoon, and good evening, whatsoever timeline you are in. This is Harita Kasturi. I am from PACE Hyderabad. Let's discuss the questions going on in our marathon sessions for chemistry. Let's continue the 2024 question papers of your JEE, which comes on number 161, 61st question. Now, the continuation we are going to do. Given below are the two statements. One is labeled as assertion and other is reason. Okay, the total number of geometrical isomers shown by cobalt N twice and Cl2 plus complex. So what do you mean by this? So we have to first draw the isomers. First of all, let us draw the isomers for these things. What are the isomers that we can draw? For what? Cobalt, ethylene diamine, see cobalt En twice. It the ethylene diamine. Diamine, is your bidentate ligand with two donating sites. And then you have Cl2 here, two donating sites here as well, right? Two twos are four, four twos are four, and then you have two. Total six is the coordination number for it, right? So how do we draw the isomers for this? So let us first draw the isomers for this. You will have cobalt, and this is octahedral complex definitely, right? This is how it looks like, octahedral complex, wherein diamine, ethylene diamine. So I would take an En here. So En is here and En is here. So both the Ens on one side is called as your cis isomer, and here a chlorine, and then here a chlorine. So everything is donating it. So I can just put your arrow marks as well there. And then total may you have a positive sign. This is one of it, cis isomer, and you have another one as well. We can go with another one like this, cobalt. You have to always draw these because this is an octahedral complex. We all know that this is 6 bache. Here it is 2 into 2, which is 4. 4 and bidentate ligand, you have two such 4, and here you have 2. So 4 plus 2 is 6 is your coordination number here. So which means it will be octahedral. And so I would take chlorines on one side and then En here and En here. This is one isomer I can go with. This is trans isomer. Trans isomer, which will be cobalt here definitely again, and with a positive sign. So we have only two geometrical isomers here. This is an octahedral complex with two geometrical isomers. The question says it has three. Sorry, three geometrical isomers, it says, which is wrong. So A is not correct, definitely A is wrong. Reason, let us see, it has an octahedral geometry, correct, right? It is definitely, so A is not correct, but reason is correct. That option is your C here, right? So just go on with your coordination compounds and all very well, D and F block elements very well. And here is your P block elements coming up, and also you have some of the other elements also, right? Borax bead test, it is very, very, very match the following things here. Borax bead test is very important equation here. It is borax bead test. What does that mean? It is MSO4. Okay, here it is, yeah. MSO4 in the presence of Na2B4O7 will give you MbO2 twice, and this will turn out to be your metal borax bead test. This is your bead test, yeah. So this is your bead test. So option 1 is going with C. Oh, option 1 is going with C in all of them. Option 1 and going up with C with all of them. So please do remember these tests as well, because these have to be remembered. This is all inorganic chemistry. You should remember these equations and all, because these are direct questions, mandatory questions always. Next, going up with number 2. So what is it 2 going up with? Charcoal activity test. Charcoal activity test would be your charcoal cavity test will be your MSO4 in the presence of Na2CO3. In the presence of Na2CO3 will give you this. So 2 is going up with D here, bache. 2 going up with D will be our answer here. So obviously the answer is only 1 here, which is option D. So rest of all also you can just go through. 3 is going with a cobalt nitrate test. Cobalt nitrate test goes with your this part. Cobalt nitrate test going with your option A there. MCO3, some metal, any metal carbonate with gives you metal oxide, and then this metal and this in the presence of these nitrates will give you this. And then flame test will be definitely next option will be your 4. So MCO3 carbonates will give you MCl2, and then and the metal positive 2 ion will be liberated out. So these things to be remembered definitely. Next option D is your answer here. Next, coming up with the next one, list the electronic configurations. This I think you can do it very well. Nitrogen, option A is going up with what? Your nitrogen coming at number 7. This is 2, 2, 3. This I'm not doing it, but you can try it up, right? This is so very easy to go with. Answer is your B here. Okay, and sulfur goes with 16 option. Yes, you can just go on doing this configuration. This is very, very easy. Even in the class 10th, you have done this. Okay, next, identify the correct statement from the below. The chromate ion is a square planar. No, what is chromate ion? CrO4 minus 2. CrO4 minus 2 is not square planar. It is tetrahedral. Tetrahedral. CrO4 minus 2. Okay, so this would be your tetrahedral complex. Then you have dichromates are generally prepared from the chromates. Is that right? What is it? Ask, choose the correct answers from the following. So option A is definitely wrong. Then let us go with the next one. Dichromates are generally prepared from chromates. Yes, it is right. Yes. Then dark green magnetite ion is diamagnetic. No, dark green magnetite ion is not diamagnetic. It is paramagnetic in nature. It is paramagnetic in nature with one unpaired electron. One unpaired electron. Then dark green color K2MnO4 disproportionates into neutral or acidic medium to give permanganates. Yes, it is correct. Then with increasing oxidation number of transition metals, ionic character of oxides decreases. Yes, because as your increasing number of increasing oxidation number of the transition metals, ion covalent character increases, right? Therefore, the ionic character of these oxides will decrease. So option E is right. B, D, E are right here. So option D would be your answer here. Next, which of the following is incorrect match? Incorrect match. So please try to gauge the question, read the question properly. Incorrect, correct, there you can go wrong. So please be very careful while you are in your examination hall. Right, now let us see what happens here. Now, incorrect. See, bacha, oxygen, it will show your, effects here. So, electromeric effects or mesomeric effect, right? Wherein electrons will be pulled down. This attains delta negative, and delta negative. There is no way that OH moves out. So, here chlorine is given. No direct substitution of this is not possible due to the resonance effect here, due to the mesomeric effect here. This is not possible, right? And whereas for option B, yes, chlorine can move out to bring up your OH, but OH cannot move out because of the mesomeric effect. And here oxygen, everything, oxygen has a lone pair. Okay, so it drops down here, takes out the positive charge, HBr and all, as you can see, H plus and Br minus, right? See, this cuts down. You have your electron coming up here, O minus बन जाएगा. O minus पे तो H plus attack होगा तो OH बन जाएगा, and CH3Br would be released out. And here also the last one, so option A will not be taking place. This is right, this is right. And here also, as you can see, this is delta negative, and delta negative. This is oxygen pair, you have lone pair, so it gets dropped in. So because of the mesomeric effect, delta negatives come in. Cl2 and AlCl3. Cl2 splits up as chloronium ion, right? This is Cl minus, Cl plus. This is chloronium ion. Chloronium ion attains on these positions, so you would be getting somewhere like this: OCH3 with Cl here, or with the Cl here, right? Or with Cl to the ortho meta para positions. Ortho position and para position, not meta. Ortho and meta positions only you would get. So out of which definitely your also not ortho and meta, ortho and para, I'm so sorry what I'm speaking. Yeah, ortho, and I have written ortho and para only. Yeah, ortho and para positions पे आपका substitution मिलेगा, wherein para position is more of a stable structure. So therefore option D is also right. Incorrect is A. Which if you don't get it, please pause it up, listen it to be back again, and then in case you still don't understand, please ask me in the next coming up class. Okay. Next, given below are the two statements given. All the following compounds react with para-toluene sulfonyl chloride. बच्चे para-toluene sulfonyl chloride देखते ही you should remember one thing there, Hinsberg test. Hinsberg test is the one which is very important whenever you see toluene sulfonyl chloride, बिल्कुल कुछ भी नहीं देखने का, you just have to go with your Hinsberg reagent. And now let us see what is your Hinsberg thing. Hinsberg goes with primary, secondary, and tertiary alkynes are NH2. See, I'm writing the Hinsberg test here. Hinsberg test. R N, this is R2, this is R1, and this is H. This is secondary amine, and R1, N, R2, and R3. This is your tertiary amine. So primary amine, secondary amine, and tertiary amine. I am using your, what did we get? Sulfonyl chloride, S double bond O, and then Cl group, right? So benzene sulfonyl chloride, क्या बन जाएगा? You have a hydrogen here. Definitely one hydrogen gets removed. ये देखो नाइट्रोजन अपना इलेक्ट्रॉन ले रहा है, यहाँ पे नाइट्रोजन इज टेकिंग द इलेक्ट्रॉन, N माइनस बनेगा, हाइड्रोजन बनेगा H प्लस, एंड देन क्लोरीन टेक्स अवे द इलेक्ट्रॉन फ्रॉम हियर, Cl माइनस बन के बाहर. So I am getting a HCl out here, this one, H plus and Cl minus, as you can notice here, H plus and Cl minus comes out. Nitrogen pe negative, sulfur pe positive, just directly attack onto this. Okay, so what do I get here? Sulfur, I am writing double bond O and double bond O here. And then your nitrogen is coming up here with one hydrogen and one R group, right? This is what you get. And this is alkyl benzene sulfonamide. Alkyl benzene sulfonamide. Okay, now इसके ऊपर if I go with NaOH, तो क्या बनेगा? NaOH, OH दिख रहा है यहाँ पे, तो हाइड्रोजन आ जाएगा यहाँ पे, right? Hydrogen comes in. So then what? Water molecule it happens to be, right? And then hydrogen अपना इलेक्ट्रॉन दे के छोड़ के यहाँ पे ऑन द नाइट्रोजन, तो N माइनस बन जाएगा, H प्लस बन के बाहर. सो वाटर मॉलिक्यूल बन गया. तो N पे नेगेटिव, which means all this group, I am just showing it in the blue bracket, all this group, hydrogen plus बाहर आ गया, it has come out. With the OH minus it went on. All right, so all this group with negative, and then sodium plus. This is a salt, sulfonamide, salt of sodium बनेगा. This is 1 degree, right? 1 degree के साथ ये बन रहा है. And this is soluble. This is soluble in aqueous solution. Soluble in aqueous solution because this is this much minus and this much plus you got. Definitely soluble in your medium. Now if I come the same thing with secondary, ओके, सेकेंडरी अमीन के साथ में करूंगी तो क्या बनेगा, डबल बॉन्ड ओ हियर, डबल बॉन्ड ओ हियर, Cl हियर. So what happens, definitely you have one hydrogen here, hydrogen comes out, H minus, Cl plus, this chlorine and this hydrogen moves out, so minus HCl बना दूंगी मैं, and same structure मिलेगा मुझे, I will get definitely the same structure. अब इसके बाद क्या होगा, that's the challenge. See, I got N with R1 and R2 here, right? And इसके ऊपर if I go with NaOH, there will be no reaction at all, right? Because there is no water, hydrogen to get moved out, to get displaced out of this position, right? So there is nothing to lose. You get nothing there, no reaction there. Now if I do the same thing with this part, R1, R2 and R3, with benzene sulfonyl chloride, what is that I am going to get? So I have no hydrogen to go off at all here, nothing to go off at all here. So therefore I would get only the test if it is my 1 degree amine. 1 degree, 1 degree will be, we will be getting Hinsberg test for 1 degree amine. That is the trick there. And to remember, you should remember, otherwise, this is how the reaction goes. Hinsberg test. Whenever you see this benzene sulfonyl chloride, p-toluene sulfonyl chlorides, also, you would definitely go with your Hinsberg test. And Hinsberg test is shown only by the primary amines. So all the following compounds react with this is being asked to us, is being told to us. Is it right? It is given by primary amines only, both statement. So here it is what? See, this is tertiary amine, galat. So this is 2 degree amine and this is 1 degree. By all of them, no. All of them, so all the following compounds, no. Only the primary amines will give the Hinsberg test. So statement 1 is wrong, definitely. Mm. And then the products in the above reaction are soluble in aqueous solution. Product in the above reaction only in the first one, only in the primary. प्राइमरी के साथ ही वो बनेगा. See this, प्राइमरी के साथ ही that will be soluble in your aqueous solution. Be aware of that as well, right? So both statement 1 and 2 are false. So both the statement 1 and 2 are false, false, false statements both. Because not everything, only the primary amines. Remember that point. I'm stressing on these points much number of times. So be very careful on that. Next, number 67, you should go with your bond line formula. कुछ नहीं है यार, bond line formula, carbon with hydrogen. Okay, you have a OH group there and then you have two cyanide groups there. Cyanide groups मतलब क्या? See, what do I mean by cyanide? Or I will show you this also. चलो, cyanide के साथ you have to go with C triple bond N. This is your cyanide group, C triple bond N. Where is the structure? So option 61, you have option B here. Acha, they are asking us the bond line formula for this. Option D, go with option D, because bond line formula is represented only by these things, not with carbons and all on the main chain carbons ke saath nahi. Bond line will have only these junction point carbons there to be shown. So option D is your answer there. All right. Next, move on. Incorrect statement regarding the conformations of ethane is. Now, what are the conformations talking about? So let us first talk about the conformations points here. So these are the isomers, these are the arrangements which we can go with. So isomers we have, and I think I will just show you one video recording regarding this, and I'm going to explain you. Just a minute, give me a moment on this. I'll explain you on this. Yes, Bache. So as you can notice this part, I'm just trying to give you a recap, of these confirmations which I'm showing you right now. 1 second. Yes. So these are the conformations of the isomer of these, carbons and all which we are talking about. As you can see, this is a skew isomer. Let us talk about skew later. Okay, this arrangement where you can see here, okay, this is your 120 degrees arrangement, and 60 degrees arrangement is the Gauss arrangement, and this would be a 120 degrees. As you know, you are rotating the other carbon. 120 is the eclipsed notation here. Eclipse is what? Like, one carbon is behind the other. Exactly. It looks like there is no other. It's like just your, trigonometry, not trigonometry, triangles. Okay, it is just like your triangles, congruency of triangles, just like that. The पीछे वाला कार्बन एंड आगे वाला कार्बन एक दूसरे से छुप जाएंगे. They just hide themselves. The backward, carbon, whatever it hides itself away in front of the first carbon. And then exactly you don't see different carbons. You will see only the front three carbons, those green, balls. You can see the front balls, the only those things you can see. But whereas as it is rotating, I'm just, removing the pause thing now. Yeah, as it is rotating here, as again, you will see the skew here, and then you have, this degrees here. It is like, staggered configuration. That is what we talk about. Staggered configuration. Three hydrogens on the front carbon are directly in front of the three. This is eclipsed. This one we have just now discussed, right? Eclipsed. And then you get a staggered configuration when all the hydrogens are spaced out at 60 degrees from each other. Like, पीछे वाला carbon and आगे वाला carbon. They both are at 60 degrees to, I mean, पीछे वाला hydrogen and आगे का hydrogen. If they both are at 60 degrees to each other, then they are, said to be the staggered configuration. And yeah, this is your staggered configuration. And then as you go on, you have the skew. That's a combination of the staggered in between, the intermediates between the staggered configuration and your Gauss configuration. That thing is called as your skew configuration, when all of them are coplanar with the first three carbons are coplanar with the rest of the three carbons. So with the backward three carbons, then it is called as, I've seen those configurations. Eclipsed configuration will be the least stable configuration, and the staggered configuration, like, if I have this three carbons here, one hydrogen, hydrogen, hydrogen. Okay, this is CH3, and the backward, I'm just using another one here, here, and here. These three are my back end of carbons, wherein I can just show you like this. Okay, this is these three, and the other ones are your these three, right? So this is like ethane. This is definitely, this is one carbon, this is one carbon, two carbons here, two carbons, and three hydrogens on each of them. Three hydrogens on each of them. So now when one set is rotating, the backward set is rotating, and then they come in this, arrangement, this hexagonal pattern of arrangement like this, right? Yeah, this one is called your staggered, and staggered is the most stable. Ethane has infinite number of conformations. No, it has got five conformations only. Okay, so incorrect statement is being asked. No, it is five conformations for ethane. And the dihedral angle in the staggered configuration is 60 degrees. Yes, this is my 60 degrees angle of one hydrogen to the other hydrogen. Here also you can see 60, 60. So all these 60s together makes up your 360 degrees, right? Six angles here, 360 degrees each. Completely. So the 60-degree angle is, your called as staggered conformation, and that is the stable conformation, or it is also called as anti conformation. So staggered, which is the most stable one. And eclipsed for conformation is the most stable configuration. Yes, eclipsed configuration, I would say here, eclipse, which means if I say the top one and the bottom. As you can see this, backward, back to back, if you have eclipsed, one carbon eclipses the other carbon, one hydrogen of the first set eclipses the other set, then it is the most stable configuration. What we say, eclipsed configuration would be your most stable. So which is also right, and the conformations of ethane are interconvertible to one another, right? So ethane has infinite number, which is wrong. Next, 61. 61, what you have, sorry, 69. You have, yeah, CO, this, okay, all these are ligands given to increasing order of your wave number is being observed here. So gallium is used in thermometer is given to you. Question number 70. Yes, gallium is used in thermometer. Why? Reason, melting point of gallium is low, whereas boiling point is high. Yes. So both A and R are correct, and R is the correct explanation for A. Definitely option A it is. Why? Because very low melting points it has, so it is very sensitive to temperatures. It can measure the temperature well, but boiling point is very high, so it is safe to use. Next, question number 71. Choose the correct answers. Okay. A, B, okay. A is your Mn2O7 is oil at a room temperature. Yes, bacha. Then V2O4 reacts with acids to give VO plus 2. Yes, this is all analytical chemistry kind of questions. Then you have CRO is basic oxide. Is that true? A, B is correct, definitely yes. And CRO is basic oxide. Chromium oxide is basic oxide. Yes, it is true. Okay, and CrO3 is acidic, but CrO3 is acidic. CrO is basic oxide. So A, B, C, correct. V2O5 does not react with acids. No, it reacts with acids definitely. Because we have just now seen it reacts with acids to give VO plus 2. Then option D is wrong. So A, B, C are correct. A, B, C. Option A is correct. Next, 72, question number 72, we are moving on. MnO2 plus KOH plus O. Okay, MnO2 with KOH will give you what? MnO2 turns to MnO4 minus kadana, MnO4 minus 2 के साथ, obviously MnO4 minus 2 के साथ, when you have K plus, this turns out to be K2MnO4, right? When you have a complex like this, when you have a MnO2 turns to, because it is being told to us, it is an oxidizing agent, MnO2 with KOH and an oxidizing agent will give you what? So plus hydrogen hai you have oxygen, you will definitely lead with your water then. And MnO2 is your dark green. Please write it down, write it down. This is dark green. Bacha, please don't go them just lose just by listening to it. Please write the important points which you do not know. That will be a very good asset for you while your exams. Next, dark green color and electrolytic oxidation in this, this is alkaline medium. So at anode क्या बनेगा? At anode क्या बनेगा? MnO4 minus will give you actually MnO4 minus plus 1 electron. MnO4 minus 2 will give you MnO4 minus plus 1 electron is released at the anode. Anode will be taking up the electron. So fusion of MnO2 with KOH oxidizing agent gives dark green. This is dark green K2MnO4, correct. This is dark green. Yes, that is correct. And manganite ion in electrolytic oxidation in alkaline medium will give you permanganate ion. This is also right. So both statement 1 and 2 are right. Next. For hydrogen atom, 3p and 3d are degenerate and degenerate orbitals have the same energy. Yes, degenerate orbitals have same energy, definitely. Yes, and for hydrogen atoms, 3p and 3d. For hydrogen atom orbitals, 3p, 3d, everything will be same only, right? So we are talking about s orbitals there. We know 1s is less than 2s is less than 2p, right? And is less than 3p. It goes on, right? So option both statement 1 and 2 are right. Next, PbCrO4 plus NaOH hot excess will give us what? It will give you a tetraionic, tetra anionic complex, which has got the coordination number 4. Okay, which has got the coordination number 4. This has to be your answer there. Given below are the two statements. One is labeled, okay, sorry. Alcohols react both as nucleophiles and electrophiles. So, what is it? Definitely, yes, it is correct assertion. And what is your reason given to you here? Alcohols react with active metals such as sodium, potassium, and aluminium to yield corresponding alkoxides and liberate hydrogen. Yes, so it is acting as both electrophiles and nucleophiles, definitely, because as it can donate the lone pair of electrons, it acts as nucleophiles, and as it takes up also, like it can act as both nucleophiles and electrophiles. So 75 A is true, definitely. A is true, A is true. And what happened to R here? Mm, R is correct, but it is not the explanation for that. See, alcohols react with active metals such as sodium, potassium, aluminum to get corresponding alkoxides. This is true. Reason is correct. Okay, but reason is true, but not the correct explanation. Not the correct explanation. Okay, next, which one is the correct metamer of this? Okay, metamers are what? The alkyl groups are differently attached. Alkyl groups are differently attached. So one on the other side, right side and left side. See this carbon dioxide, carbon and oxygen ke saath. Onto the right side you have benzene ring. Onto the left side you have all this. Here onto the right side you have just the halo structure here and cyclostructure, and this your benzene structure. Option A, this will be your metamer. Metamer ke liye, like R O R dash R double dash O and then R somewhere, because your this part should not change. Right side and left side, the carbon chain would change. That is your metamer. So option A is right. I don't see anything else there, because C double bond O ke saath, as you have to go here, both coming on to the right side. No, it is not right. One, you should have carbon chains on both the ends, definitely, but the number and all should change. The structures should change. Next, identify the factor from the following that does not affect electrolytic conductance of a solution. Nature of the electrolyte will affect nature of the electrode use. I'm just putting it up one blank on this. Concentration of the electrode will affect, nature of the solvent will affect. So option B. Okay, so identify the factor from following that does not affect the electrolytic conductance. Electrolytic conductance, nature of the electrolyte, the concentration of more the concentration you put, less will be the conductance. More diluted version you put, more of the conductance you see. Nature of the solvent also. The solvent should be able to dissolve that, so that you will furnish a lot of electrons, a lot of ions there, right? So therefore, all A, C, and D are the options. Nature of the electrode is not mandatory for it. Next, number 78, the solution from the following with highest depression in the freezing point. Depression in the freezing point will be what? 180 grams. All of them are 180 grams. You have acetic acid, benzoic acid, and all. Okay, acetic acid dissolved in water. This is weak acid, definitely. Okay, dissolve in benzene. No, acetic acid will be dissolved in benzene perfectly. So not this. acetic acid dissolved in water will be a better option for this solution from the following with highest depression in the freezing point. Now, how do we go with that? So we need to first find out the alpha point there. And we know I is equal to 1 plus alpha. And what is I there, which is 180, because that is your acetic acid wala 180 by water is 18, and you have five of them. So sorry, by 60 you would get your this thing as 3. And you don't need to do all this conversion also, because और चलो लिख लेते हैं delta TF is equal to 1 plus alpha times KF. Constant remains constant only, right? So you just have to compare with all the three and check out. Then you will get this as, wherever your I into M is the maximum thing, that will be your answer. Option A is your answer, because acetic acid dissolved in water will be more ideal. Benzoic in benzene and all, they will be dissolved, right? So water ke saath you can go with this part. And glucose cannot dissolve in water, definitely. No, sorry, glucose can be dissolved in water. I'm so sorry. Then shape of the carbocation, number 79, shape of the carbocation is what? So carbocation, carbon with three hydrogens and one positive charge. One electron went out, right? So it would be a trigonal planar, right? It looks something like this, right? With a positive charge, trigonal planar. Next, question number 80, you have KMnO4 plus C2O4 minus 2, oxalate ion, C2O4. C2O4 plus, see, this is what is C2O4 minus 2, looks like. This is negative charge here, negative charge here. Okay, and will give us what? In the presence of acidic medium, KMnO4 के साथ तो MnO4 minus, we know D block किया हमने, हाँ? MnO4 minus in the acidic medium will give us what? Always Mn plus 2. And then C2O4 minus 2 will give you CO2, carbon dioxide in the medium. And find the change in the oxidation state of Mn. That's what they say. What is the change in oxidation state? Here, manganese has got a oxidation state of plus 7, right? Manganese, we don't know. I'm writing it as X, and each oxygen is minus 2. Minus 2 times 4, which is minus 8, is equal to total charge is minus 1. X is equal to 7 here. 7 to 2. 7 to 2, the change is 5. Oxidation state of Mn is change in the oxidation state asked to us. Change in the oxidation state is 5 here. 5. In the same way, agar if they also ask you carbon ka kya hai scene, so here you can go with carbon also. 2x minus 8 is equal to minus 2. 2x is equal to 8 minus 2, 6. X is equal to 3 here. And here carbon ka x minus 4 equals to 0. X is equal to 4 here. Change in the oxidation state for one carbon, it is 1. For two carbons, it would be 2, right? Anyway, that's not asked to us, but in case asked to you, you can do that as well. Next, question number 81. Correct increasing order of the bond angles between BF3, PF3 and ClF3. Chalo. BF3, PF3, ClF3. All of them are fluorines only, right? So you don't need to compare with the fluorine there, right? Because they are asking, this is from the, this part. I can see very well, very clearly option C is your answer. Why? Why? Tell me. Chlorine, see, as you can notice this one, correct increasing order. First, boron will have very least and greatest angle. You can see, increasing order of the angle is BF3 here, boron. And why? Because you are having fluorine is more electronegative, will draw the electrons towards it more efficiently like this, right? So more efficiently they will draw the electrons, because if the electrons are coming coming closer to the central atom, see, remember one thing, electrons, if they come close to the central atom, repulsions होंगे and the bond angles will expand. So close तो नहीं आ रहे, सब लोग पीछे ही जा रहे हैं, तो पीछे में कम पीछा जो जा रहा है, that will have a better angle. कम पीछा जो जा रहा है, that will be for your boron part, right? So this would be your thing. So BF3 will be having the greatest, then PF3, and then your ClF3. Option C is the correct one. Next, moving on, number of complexes with even number of electrons in T2G orbitals is, so this goes up with your crystal theory, bacha. I would explain you the crystal theory in class. Don't worry about that. Otherwise, let's do, no problem. Let's do. See, Fe here, I would just go with, I'm just trying to write it in another page then. Yeah. This is better. We will go. Yeah. So this is FeH2O 6 times with +2. And then COH2O 6 times with +2 here. And then you have COH2O 6 times with +3 here. Then you have CuH2O 6 times with +2 here. And then CrH2O 6 times with +2 here. Okay, so now first let us see FeH2O 6 times. Fe will be with +2 because H2O is neutral molecule. Implies Fe goes with +2, which means D6. Right, I need to show D6 there. So D6 may d orbitals will be going on with degeneration. One second, let me see whether my ligand is the stronger ligand or a weak ligand also. That also matters here. H2O, yeah, right. So we have, see, but H2O is a weak ligand. NH3 is a strong ligand, right? So H2O is a weak ligand. So weak ligand ke liye, I would definitely go with my this part. One second, yeah. So your lower complex will be your T2G, and upper will be your EG complex there. And yeah, D6 you are filling, this is a weak ligand, and weak ligand ke liye you have these things filling up 6 electrons we have to fill. I would fill 1, 2, 3. Weak ligand, energy gap is less. Energy gap is less. Therefore, 1, 2, 3, 4, 5, and then 6 here. You have to fill it up this way. 1, 2, 3, 4, 5 upper, and then 6th in the repetition one. Okay. So you have T2G may you have 4 electrons here, and EG may you have 2 electrons. And similarly go on with this cobalt +2. Cobalt +2 में जाएंगे तो you have D7. Cobalt +2 will be having D7. So D7 में same thing again. It is a weak ligand. Weak ligand में तो नीचे आपका dx dy dz orbitals, and upper will be your dx and dy, dx square minus y square and dz square. So that would be Eg upper and T2G lower. And D7, we are talking about 1, 2, 3. And this is a weak ligand. Carbon H2O is again weakly 1, 2, 3, 4, 5, 6, and 7. So T2G may you have here only one unpaired electron you have. See, that one will be your 4 here, right? And totally you have total 1, 2, 3, 4, 5. T2G may 5 electrons. EG may you have 2 electrons here. Okay. Next, cobalt with H2O 6 times and +3. Cobalt with the +3 will be D6, right? Cobalt with +7 is D7, +2 is D7, and cobalt with +3 will be D6. D6 may you will go like this, and yeah, like this. D6, I have to fill up 6, electrons. So here the gap is more. Here EG and T2G. 1, 2, 3. Gap is more, so therefore 4, 5, 6. 6 electrons filled up here only. And this is diamagnetic in nature, no unpaired electrons at all, right? So this would be my हाँ और पहले से हम ये भी लिखेंगे चलो we will write this also for the first one T this is even we got. Let me go with another color. Which color? Yeah. So this will be with T4 will be even here. This is odd configuration we got. And here it is 6. Again, even configuration we got. And then copper with plus 2. Copper with plus 2 would be 9 electrons, which means D9. D9 electron may you will split them into your orbitals here, taking them as you will start from the lower only always. 1, 2, 3, then 4. You have lower gap only, less gap or less energy gap. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. So only here you have in your T2G, you have 6 electrons in your T2G, which is even. Then you have chromium के साथ भी कर लेते हैं, chromium with plus 2, and which means it is having D4, right? Chromium with plus 2 and D4. So D4, same again, you split them into your orbitals. I'm going with a lesser energy gap, 1, 2, 3, and then 4, EG and T2G. T2G is for this. And T2G may you have 3 electrons, which is odd. 1, 2, 3, as you can see here, which is odd here. So that is how you have to fill these things. And when I see the question again back, the question says number of complexes with even number of electrons in T2G orbitals. Just count it and okay, you will get the answer there. Just count them. Number of electrons, how many here you have with even number. Even is how many? 1, 2, and 3 even number and 2 odd you got. That's it. That would be your answer there. Next, even number is 3. Odd number पूछा तो 2. Okay, next 83. For the reaction K1 is from A to B, and from B to C it is K2. Okay, rate of formation of B is said to be 0. Then the concentration of B is given by what? So which means rate of formation of B, dB by dt is equal to K1A minus K2 times the B concentration, right? So when I do this, this is 0 is given to you as, a rate of formation is 0. So this is 0. 0 is equal to K1 into concentration of A times minus K2 times concentration of B. So ये left side में जाएगा. So K2 concentration of B is equal to K1 concentration of A. So K1 by K2 times concentration of A is equal to concentration of B. So you're asked about concentration of B is how much? K1 by K2 times A. K1 by K2 times A. Option D will be right here. Because it has been told to us the rate of formation of B is set to be 0. A to B and then B to C. Right? So, or else just, first write down. So, K1 kya hai? Concentration of B by concentration of A, and also rate depending on the first thing, rate depending on the second thing. So, you just subtract those two equations to solve them. That's it. Right? Next, moving on, 84. Yeah. Since fluorine is more electronegative than nitrogen, net dipole moment of NF3 is greater than NH3. Chalo, I will just first draw. This is NF3 and this will be my NH3. Okay. One second. Just draw. And this is NH3. Okay, so now what is happening here? Which has got a better dipole? One second, let me just draw it carefully with regular shapes only. One second, I'm so sorry. Yeah. Nitrogen with pyramid structure, fluorine, and then a lone pair, right? And similarly, you will be having nitrogen with a pyramid structure of hydrogens and then a lone pair. So here, lone pair definitely will be pulling you upward. Okay, high fluorine will also be pulling you downward. So net dipole is neutralized here in the first option. Whereas in the second option, here hydrogen is giving away. So therefore, you can see the movement in the upward direction in the second case. Whereas in the first case, you have topward movement and the bottom, because fluorine is more electronegative than nitrogen. Nitrogen will be pulling the fluorine will be pulling the nitrogen downward. So therefore, here, as you can see, the net is almost zero, almost, I would say nil as compared to option B. Since fluorine is more electronegative than nitrogen, net dipole moment of NF3 is greater than NH3 पूछा. Is that right? गलत. Right? Because net dipole moment second one का ज्यादा है ना, NH3 का net dipole ज्यादा. Right? Then NH3, the orbital dipole due to lone pair and the dipole moment of NH bonds are in opposite directions. But in NF3, the orbital due to them are in the same direction. गलत. NF3 में opposite directions में है and NH3 में same direction में है. You notice that, बच्चे? This is from the chemical bonding, first chapter, first year, right? NF3, fluorine is more electronegative, bringing down the electron. Nitrogen pulls to the electron to the other side. Both the sides you can see here in your option, in your the first case, NF3 case. So both the statements are false. Both statement 1 and statement 2 are false. दोनों भी गलत. Okay, next, identify the correct statement here. About the p block elements and their compounds. Okay, what are your correct statements? One second, let me non-metals have higher electronegativity than metals. Perfect. Yes. Non-metals have lower ionization enthalpies than metals. No, metals have good lower ionization enthalpies, because ionization enthalpy matlab kya hai? Ionization enthalpy means energy given to an atom to release an electron. Metals are easily removing electrons. They don't want much of an energies to be given in. So low metals के लिए low ionization energy रहेगा. They say non-metals have low ionization. गलत. Next, option C, compounds formed between highly reactive non-metals and highly reactive metals are generally ionic. Correct. Highly reactive non-metals has the tendency to take up electrons and become negatives, and non-metals are negatives, and metals will have tendency to gain positives, and there will be attraction between them. Yes, option C is right. This is also your chemical bonding chapter se hi hai from the first year. Next, the non-metal oxides are generally basic in nature. No, bacha, non-metal oxides are acidic in nature, right? So option D is wrong. Metal oxides are generally acidic or neutral. No, generally basic or neutral. Metal oxide or amphoteric, not neutral, amphoteric in nature. Metal oxides are basic or amphoteric in nature. Option A and C only, which are true here. Okay, next, given below are the two statements given to us again. Yeah, you are asked to find the IUPAC naming for it. All right. So OH here, CH2 three times. See, I'm just trying to draw it again. OH here, CH2, CH2, CH2 three times, fourth time CH2, then COCH3. So it is my CO and then CH3. This is how it is we have to go with, right? And what is the name for it? COCH3. Yeah. No, it is only CH2. Oh, it is only CO, bacha. Sorry. It is only CO. There is no CH2, na? So it would be ketone. COCH3, right? C double bond O and then CH3. Yeah. Here it is COCH3 star here. See, this one is the star mark, what I'm talking about. COCH3. This would be a ketone, definitely. And when there is a ketone group, that will be your main group. OH will be your substituent group called as hydroxy. that becomes your substituent group, hydroxy. Now number it, number the chain. So definitely your functional group, which is your ketone group. Ketone group should be preferred. 1, 2, 3, 4, 5, 6, 7. So I would say 7 hydroxy. 7 hydroxy, yes. This is heptan 2-on, correct. So IUPAC naming for this is correct. Option A is correct. And what is that they say? This is the correct, I know. Octa nahi, oxo nahi bolte hai. Okay, this is hydroxy. All right, next move on. Total number of correct statements regarding the nucleic acids is um what is the correct statement? Total number of correct statements asked to us. Okay, then DNA is the protein synthesizing cells. Yes. RNA is regarded as reverse. No, no, no. Anyway, you don't, you do have this, right? Yes, yes, yes. RNA is regarded as the reverse of genetic information. False, bacha, false. DNA molecules self-duplicates. Yes, it is true. DNA synthesizes proteins in the cells. No, no, no. It is no, false. Then RNA has got ribosomes. No, they have these protein synthesizing cells. Then message for the synthesis of particular proteins is present in the DNA. True, yes. Then identical DNA strands are transferred to the daughter cells. True, true, true. So please remember these things. This is all your theory part. Definitely. So how many total number of correct statements we got? Yes. Next question number 88. NiCH3 tries and PCH3 tries can act as ligands to form transition metal complexes. Is that right? They say. Just check out yeah, NiCH3 tries nickel with 3 CH3 groups, and yes, they are both Lewis bases. Okay, Lewis bases, they can donate, definitely. They act as ligands. Phosphorus only, see, this is phosphorus and you're just putting CH3 and CH3 now. So you still have two electrons as the lone pairs. So lone pairs, and you have the lone pairs. This acts as a Lewis base and acts as a ligand. However, P with CH3 has a pi accepting character as well, right? Then I would say statement 1 is correct. Yeah, no, incorrect kadu. Statement 1 is correct. Statement 1 is correct. Then statement 2 kya hai? Statement 2, as nitrogen and phosphorus are from the same group, the nature of the bonding is always the same, Antonado. Is that the same? No, it is not the same. Why? Because nature of the bonding. Acha, one second. With the transition metals, nitrogen does not have the d orbitals, na bacha. So the nature of the bonding will not go the same with the transition metals, because you are having transition metals के लिए d orbitals and all, wherein nitrogen do not have the d orbitals to go with. Phosphorus does have vacant d orbitals to go pair up with. So therefore, the nature of the bonding is not the correct, is not the same. So statement 2 is incorrect. Option C is your answer there. You need to check up, although they belong to the same group, but nitrogen has got, it is in the second, right, shell, so it does not have any d orbitals to go with. Next, thiosulfate reacts differently with iodine and bromine in the given reaction. Okay, what is it talking about? Reaction of S2O3, 2 minus with iodine. Okay, it will give you S4O6 and all. Changes to what is that they are asking about, which is the following statement justifies the above dual behavior they are asking about. Reduction or oxidation, that is what they are talking about. So first let us write down S2O3 2 minus gives you iodine, so plus iodine, sorry, plus iodine. It's not gives you, no, plus iodine, I2 will give us S4O6 minus 2 plus I minus. As here, this is neutral to negative, which means you're decreasing on the number line. Reduction is going on here. reduction, and here it is what? This is 2x minus 6 is equal to minus 2, because 2x, because sulfur you have 2, each oxygen is minus 2 times 3, which is minus 6, is the total minus 2. So 2x is equal to minus 6 to the right side, plus 6 minus 2, which is 4, x is equal to 2 there. And here 4x minus 12, each oxygen is minus 2, and you have 6 oxygens. Minus 2 times 6 minus 12 is equal to minus 2. 4x is equal to 10. X is equal to 10 by 4, which is 5 by 2, which is 2.5. 2 to 2.5, you are increasing on the number line. You are going up with oxidation. Now, what is that they say? Thiosulfite reacts differently with, let us go with the bottom one as well, right? S2O3 2 minus के लिए you have how much? Plus 2 oxidation state. SO4 के लिए कितना? SO4 minus 3 दिया है वहां पे, right? S is X, SO4 minus 3. S is X, minus 8 is equal to minus 3. X is equal to plus 5. Here it is plus 5. Now tell me what the question is about. Which of the following statement justifies the above dual behavior? Both are going on with the oxidation only in both the cases, but bromine is a stronger oxidant than iodine. Bacha, remember that point. Both are going the same way, but bromine is a stronger oxidizing agent as compared to your iodine. Remember this point. Okay, please write this point separately. Next, both metals and non-metals exist in P block and D block. Is that right? Just think. Both metals and non-metals no exist in P and D block element. No, D block elements, non-metals do not exist. Metals only. Transition metals you have D block. So statement 1 is false. Statement 1 is false. Statement 1 is false. Statement 1 is false. Then my option is in A and B only, right? Now let us talk about with the statement 2. Statement 1 galat. Non-metals have higher ionization enthalpy and higher electronegativity. Non-metals higher ionization enthalpy. Is it true? Yes or no? Yes. Metals have lower ionization enthalpy because metals don't need much of an energy to release as compared to non-metals, right? So option, this one is right. And higher electronegativity, yes or no? Yes, it is. So statement is true. So statement 2 is true. Statement 1 is false. This is again on your first year syllabus, right? So higher electronegative non-metals have got better electronegativities because they want to grab the electron always. So option 2 is, statement 2 is right. Which of the following has allylic halogens? Now, what do we mean by allylic halogens? Also go with that. So allylic halogen is double bond के बगल में vinyl and allyl groups. Vinyl is on the close vicinity on the double bonded carbon. Vinyl on double bonded carbon. Allyl, allylic group, double bonded carbon के बगल वाला carbon पे if you have something, that is what is called as your allyl group. अब अलाइल कार्बन के बारे में पूछा है, डबल बॉन्डेड कार्बन के बगल वाला कार्बन पे हैलोजन. सो दिस इज राइट. सी, डबल बॉन्डेड कार्बन के बगल वाले कार्बन पे नथिंग. डबल बॉन्डेड कार्बन इज हियर. आई थिंक माय कर्सर इज मूविंग ऑन हियर. यू कैन सी दिस. डबल बॉन्डेड कार्बन इज हियर. उसके बगल वाला कार्बन मतलब ये, इस पे तो कुछ नहीं है, राइट? सो डबल बॉन्डेड कार्बन तो डी में है ही नहीं. सो ऑप्शन सी इज योर आंसर देयर. Right? Write down vinyl is double bonded carbon pair substitution, whatever you're talking about. And allyl is double bonded carbon ke next carbon pair if you have something, that is allyl. Next, correct stability order of the resonance structures is what we want. Yes, let me just check. 1, 2, and 3. You have 3 structures given to us here. And which is the more stabilized structure. Bachche, you can see charges on first and second. So first and second are not so stable as compared to third. Third one, you don't have any charge on it. So third one is rather more stable one. So my answer I got option B. Okay, I'm just trying to tell you why is option B second and third. Then I would say second. Why? Because oxygen can handle the negative charge easily as compared to the positive. So this is very unstable, very unstable as compared. First one is very unstable because oxygen by positive charge. Na, baba. It's ego hurts because oxygen is an electronegative element. So oxygen can handle the negative charge easily. Having no charge is the best, which is the option third. So third is more stable, then number two, then number one. That is how we go. All right. So next, question number 93. Choose the correct answer. All right, let us choose the correct answer. What is it talking about? Again, this is your analytical chemistry question. We need to go with your SCN पूछा तो blood red बच्चा. SCN is blood red. Remember that SCN blood red, SCN blood red. Just go on revising these things there. NO with S is your violet complex. NO nitroso. Okay, this will be your violet complex. That's it. That will give you the answer. 3B. 3B कहाँ पे है? 3B में दो है बच्चे. 3B में एंड 2A में भी दो है. वेरी गुड. नाउ वन विथ C और वन विथ दैट. Let me go with molybdenum. Molybdenums are, molybdenum oxides are yellow in color, bacha. Remember, this is D, 4D. So option A is right. Okay. Option A is right. So that is how you can go with SCN is blood red. Remember, NO, cyanides with NO with that will be going up with your violet color complex, and molybdenum yellow color. You can go that. Next, given below, SN2 are stereospecific, indicating that they result in the formation of only one stereoisomer as the product. It is about your isomerisms and all, bacha. SN2 goes with inversion, right? Inversion. Whereas SN1 with racemization, racemic mixtures, racemizations, it will go with, right? So SN2 reactions are indicated stereospecific, they are stereoisomers, indicating that they result in the formation of only one stereoisomer as the product. Yes, stereospecific, one stereoisomer, correct. And SN2 formation of the product as the racemic mixtures. Yes, in the light of the above statements, both are right. Statement 1 and 2 both are right. Right, this is your haloalkanes chapter, the first chapter of your organic year in your grade 12. SN1 and SN2 statements go on. 95. Which of the following compounds will give the silver mirror with ammonical silver nitrate test? Silver mirror test is shown by this compound, bacha, HCHO with OH group. This group should be there, aldehyde. Okay, there should be, apart from the aldehyde, formic acid also gives the silver mirror test with ammonical silver nitrate solution. Formaldehyde will give definitely formaldehyde. Remember this silver mirror test, formaldehyde will show the test. Write this point also there, okay, in your catch book, in your book where you are writing everything, please write it down. Otherwise, you would not remember. And before your exam, you can just go on flipping your questions. That will be easy. Tips mein likho, pause it, likho, then go with the next question. Then 96. Oh, one second. We have to go with formaldehyde to definitely show karega ही. Formic acid भी show करेगा. What is formic acid? So H, C double bond O, OH. This is formic acid. You can see this. Then benzaldehyde. Benzaldehyde is benzene पे. It is CHO group. You can see this. Acetone नहीं दिखाता बच्चा. A, B, C. So HCHO. I mean CHO group जहां पर भी दिखता है, that will show, aldehyde will show your silver mirror test. Remember that. Although it is aldehyde, your formic acid also shows the test because you can see this HCHO group here also. That's the reason. Okay, so formic acid also will be showing A, B, C only will be showing this. Next, 96 organic here. NaNO2 and HCl, bacha, NaNO2 and HCl, we have done it so many number of times. NaNO2 and HCl will be giving you what? One second. Diazonium salt formation. Okay, diazo salt ban gaya. What is the diazo salt? N2Cl, right? N2 plus and Cl minus. And then you have copper chloride and HCl, Sandmeyer reaction, right? You will have a chlorine there, chlorobenzene ban jayega. And then NaOH, chlorine bahar niklega. And then you will have OH here. बच्चा OH निकल के chlorine नहीं आता because OH में oxygen gives in the lone pair, whereas chlorine also does have the lone pair, gives in, but it has more tendency to move out. So it will not be going like this. इसका delta positives बनने का chances है वैसे. So therefore don't go with this as the structure there. So delta chlorine will not do that. Chlorine जाके OH नहीं आएगा. OH जाके क्लोरीन आएगा. सो क्लोरीन जाएगा तो OH आ जाएगा, बट OH जाएगा तो क्लोरीन कभी नहीं आता है. रिमेंबर दैट पार्ट. Okay, so definitely my final product is OH. OH, benzene with OH, which is phenol. Next, how many of the transformations given below would result in aromatic amines? That is what your question is about. This you can see C double bond O NH2 is amide pe bromine and NaOH. This is what? This is definitely your Hoffman bromamide degradation, HBD. Hoffman bromamide degradation में we have done it so many times. Tip क्या है? C double bond O हटा दो. Just remove it. And then क्या बनेगा? You are left out with benzene with NH2. You are left out with this part. Okay, so definitely this is aromatic amine तो बनेगा ही. Next में क्या है आपका? You are given this part. NK with chlorine. NK with chlorine तो नहीं होगा. K plus and Cl minus तो K plus चला जाएगा Cl minus के साथ. So that part will come here and that is not your aromatic part completely, right? So ये तो नहीं बन सकता है. NO2 with hydrogen, let us see. NO2 with hydrogen, this is reduction. क्या बनेगा? Your benzene structure with NH2. Yes, aniline बन रहा है वहां पे. Aromatic molecule है ये. Okay, then NHC double bond O CH3 with dilute H2SO4. Dilute H2SO4 में क्या होगा? It will be a reducing agent. It will turn back to your aniline NH2, right? So NH2. This all the structure would move out. NH, this is NH2 बन जाएगा यहाँ पे. So aromatic D, C, and A. How many of these transformations? All these three will give, but not this middle one will not give. Option B will not give. Then 98 alkaline oxidative fusion of MnO4. Alkaline बोला है आपको, कोई बात नहीं. MnO4 की no, MnO2, sorry. First, let us go with MnO2. Definitely turns to what? Your MnO4 minus 2 में convert हो जाएगा. Right? This you should remember. And अब balance कर लो. अब balance you do it the balancing part. You have two oxygens on the left side. So two water molecules here. So two water molecules मतलब 4H plus on my right side. Now let us also check out with what we are going up with. Mn, my hydrogens are balanced, my oxygens are also balanced. And now let us also balance the charge here. Now you have H, so sorry, this is plus 4 and minus 2 here. And it is not balanced. One second, bache. Mm-hmm. MnO2, Mn, yeah, कहाँ गड़बड़ गया रे? Oh, for 1 second, 1 second. I'm again drawing this. Ah, yeah. So MnO2 will be giving us MnO4 minus 2. Okay, MnO4 minus 2. Oh, MnO4 minus 2Q. Now, yeah, MnO4 minus. Now what? Yeah, you have four oxygens on the right side. So I want two more on my left side as well, two H2O here. And then I'm adding four hydrogens on my right side, 4H plus. No, still something is missing out. You're not balanced here. Let me read out the question again totally. Electrolytic oxidation. You will have oxygen released there, bache. Okay, sorry. I'm so sorry. I didn't read the question properly. Alkaline oxidative fusion of MnO2 gives a which on electrolytic oxidation in alkaline solution. Okay, so I would say MnO2 plus alkaline बोला तो चलो OH minus alkaline oxidative so O2 now will give me what MnO4 minus 2. Then how many water molecules I will be having up here? My charges also I have to go with Mn. Let me put a 2 here and 2 here. Yeah, then you will have 2 water on the right side and yeah, 4 OH minus. Right, correct. Yes. So now what is that given to us? Products A and B are asked to us. Option B दिख रहा है MnO4 minus 2 तो एक product है and this MnO4 minus को वापस करेंगे तो you will get MnO4 minus. MnO4 minus 2 will turn on to MnO4 minus. Option B is your answer. D block question this is. Next, order of relative stability of the contributing structure is, we just now have done this, I guess. Yeah, yeah, relative stability order. We just have now done that, right? So first is option 1, then 2, then 3, because oxygen पे negative चलता है, oxygen पे positive नहीं चलता, oxygen पे neutral चलता है, बढ़िया चलता है. So 1, then 2, then 3. So option for 99, option A is your right one. Next, consider the following sequence of reactions. Yeah, NH2 with N2Cl आना है तो NaNO2 and HCl, right? Because you are forming your diazonium salt, NaNO2 and HCl for sure, for sure. So this you have both the things here. Then you turn out to be what? Then you turn out to be your orange red dye bola बच्चा यहाँ पे. Be very careful there. So that would be phenol, orangish red color dye, which is your phenol. Phenol is acidic in nature, acidic, right? So therefore, this is how it is. Next, next. Yeah, 101. So we've finished 100 questions. Yay, clap for yourselves. Yes. Given below are two statements. Statement 1. Noble gases have a very high boiling points. Is that right or wrong? Yes, noble gases have high boiling points. Hmm? No, I would say statement 1 and statement 2 both are false, are monoatomic true. They are held together by strong dispersion forces. Because of this, they are liquefied at very low temperatures, hence they have very high boiling points. Very high boiling points. No statement in the light of atmosphere, which are correct. They say statement 1 is false, bacha. They have very high boiling points. Statement 2 is correct. Yes, are held together by weak dispersion forces. Strong dispersion forces गलत है. Weak dispersion forces. Okay, they have high, they have low, okay, because weak dispersion forces hai to low boiling points rahenge, right? Not stronger ones. So one is false, and two is also false, I would say. Strong nahi, galat. Weak dispersion forces hona chahiye. Next, order of spin, magnetic moment पूछा है यहाँ पे तो आपको, right? So let us go with this question number 102. Yeah, just go with those, Fe, iron with F6 and -3, which is iron has to be your, this is fluorine is -6 turns to the right side, -6 +3, which is +3. Iron is +3 here. Then +3 matlab you will have 3d5, right? +3, which means 3d5 banega, which means n is equal to 5. 5 unpaired electrons rahenge. 5 unpaired electrons under root 5 into n into n plus 2, right? N into n plus 2, which is under root 5 of 5 plus 2, which is 7, which is 35 ka under root for the first one. This is for the first option. And V with vanadium with water, and also vanadium goes with V with +2, which is D3 ban jayega iska, which means N is equal to 3 electrons, which means magnetic moment is under root 3 of 3 plus 2, which is 5, which is root 15 ban jayega aapka magnetic moment here. And iron ke liye Fe with +2 here. Fe with +2 matlab n is equal to 5 na, D4 ban jayega. Fe with +3 is D5, and with +2 is D4, which means sorry, D6, 3d6. Yeah, 3d6 मतलब 6 electrons में क्या होगा? 3 4 5, हाँ, 1 2 3 4 5 and then 6 unpaired electrons are 4 only here. So which means under root 4 of 4 plus 2, which is 6, which is 2 root 6, or you can say root 24 only लेने दो. Root 24, this is option 2, and root 24 option 3. Option 1 is root 35. Now you consider, that's it. You just have to put them in order. That's it. Okay, next move on. Number 103. 246 trinitrotoluene is known as picric acid. Yes or no? Sorry. Mm. Now you have phenol can be converted to picric acid by addition of concentrated HNO3. So let us see that picric acid is what, bacha? What is picric acid? You have OH there, NO2 here, NO2 here, and NO2 here. Okay, so statement 1 गलत है. Statement 1 क्या बोला? 246 ट्राइनाइट्रोटोल्यूइन बोला. No, it is not toluene. Okay, this is OH group, phenol. Phenol group is picric acid group, right? So trinitro, and then this is phenol is your picric acid. And ab kya bola? Phenol can be converted to picric acid. Okay, this is my phenol can be converted to picric acid in the presence of concentrated HNO3. Yes, which is right. Concentrated HNO3 पे कर सकते हैं हम, definitely. Nitration कर सकते हैं. In excess, definitely yes. Statement 2 is true. Statement 1 is false. Option B is right. Yes, option B. Statement 2 is correct. Statement 1 is false. Trinitrotoluene nahi bachcha, phenol. Next, consider the oxides of the group 14 elements of, okay, the amphoteric oxides are, what are amphoteric? SnO2 and PbO2, bacha, lead. And along with that, see, this is for the group 14, to theek hai. Otherwise, also you have zinc oxide, PbO2, definitely, Al2O3, all these are your amphoteric in nature. Remember that SnO2, PbO2, zinc oxide, aluminium oxide, all these are your amphoteric oxides. Remember that. Next, match the list 105. Bromine water test. Bromine water test may you will have this reddish orange color disappears. Bromine water reddish orange color में रहेगा definitely, and in that test as you do it, this reddish orange color disappears. One with B कितने में है? Option B में है only one thing. Yeah, one with B is right. And ammonium nitrate test, we have already done that also. Number 2 with C, red color disappears. Ammonium nitrate में red color रहेगा, that disappears. This is all your volumetric analysis questions and all. So remember 2 with C, the ammonium nitrate test, red color appears there. Next, number 3, ferric chloride test with your blue, green, violet or red color appears. Yes, it is right. It appears with dinitrophenyl hydrazine test, bacha. Okay, then 2 for this dinitrophenyl with a yellow, orange and red precipitate is formed. Remember, you should remember these things. All right. Next, please write it down. Pause it up and write it down. And bromine water is done for the test of unsaturation. Unsaturated compounds will be showing your bromine water test there. Remember that. Next, ratio of the shortest wavelength of the Balmer series to the shortest wavelength of the Lyman series in the height. This is your atomic structure question again. First year question. Lyman series and wavelength. We know about the wave numbers. Wavelength के बारे में पूछा है. So h by lambda is equal to 13.6 of 1 by n initial square minus 1 by n final square. This is what we do. And for that, if you see Balmer series and Lyman series, so just substitute the numbers. तो आपको क्या बन जाएगा यहाँ पे? This is 2 by 1 the whole square बन जाएगा बस. Question you should be knowing, you should be remembering your Lyman series, Balmer series, Paschen series, bracket series, and fund series. Here, your Lyman series N1 starts from 1, 2, so on. Here, 2, 3, so on. 3, 4, so on. 5, 6, so on. 6, 7, so on, right? So here it is one shortest wavelength for the longest transition. Your n final would be infinity. N final is your infinity there also and here also. Both the things, n final is infinity. So it is 1 by n1 square minus 1 by n2 square. 13.6 times 1 by 1 square is 1 only. And for the second one, for this is for the Lyman series. And for the past Balmer series, 13.6 times 1 by 4 बन जाएगा. 2 square ना, 1 by 2 square तो 4 बन जाएगा because infinity वाला तो 0 बन जाएगा. 1 by infinity 0. So now 13.6 goes off. This would be your 4:1 there, right? Next option, yeah. 4:1, option A will be the thing there. In which of the options all the elements have D10 configurations in their ground state? So zinc definitely D10 ఉంటుంది, cadmium definitely D10 ఉంటుంది. Okay, then copper. Copper is also 3D10, 4S1. Remember, copper also has an exception. 3D10, 4S1. So D10 copper also has. Ag silver is 4D10 and 5S1. Chestu, you should be able to remember. Okay. And next, move on. Ground configurations are these things. Next, fuel cell using hydrogen and oxygens as fuels. Which is correct, I guess, the question. Yeah, fuel cells using hydrogen and oxygens as fuels has been used in spaceships. And it is type of galvanic cell, definitely. Fuel cells are used in spaceships. Yes, definitely yes. And acha, so you have, and this is a type of galvanic cell, definitely. Fuel cells are your galvanic cells. ఒక నిమిషం అరే రే 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 1 second. Efficiency 40%. No, not at all. Uses aluminium as a catalyst. No. It is not aluminium as a catalyst. No. And it is a type of definitely galvanic cell, eco-friendly. Okay, you can go with eco-friendly also. A and E definitely yes. A and E. So you can go with D also. Yes, eco-friendly also. This is fuel cell is eco-friendly. So option D is right there. Next, 110. Higher oxidation states are more stable group among the transition elements, unlike the p block elements. Is that right? On moving down the group in the transition elements, stability of higher oxidation state increases. Bacha, remember that. Take that point in the transition elements, especially in the not P block, in the transition elements, unlike P block, they say yes, in the transition elements, definitely among the transition elements, as we move down, stability of the things increases. Stability increases as your oxidation state increases. Oxidation state increases, stability increases due to the increase in the effective nuclear charge. Reason, increase in the effective Z effective increases, then transition elements के लिए this is right. But unlike P block में inert pair effect आ जाएगा. You will not go with that. Okay, so P block elements में as you go on increase the down the group, lesser oxidation state is stable, not the higher ones. Higher ones become unstable. So unlike that, it is right. Statement 1 is definitely right. Statement 2, copper cannot liberate hydrogen from the weak acids. Yes, it is also right, right? Because copper कहाँ आएगा? Hydrogen के नीचे आता है ना copper. So it cannot liberate the, hydrogen from the weak acids, definitely. So 110 में statement 1 and 2 both are true, correct? Yes. Next, moving on, choose the correct statement about the hydrides of the group of these elements. Hydrides of the group of a group of elements. Stability order of mm, the group 15 elements. Stability of the hydrides decreases in this order. They say NH3 is more stable than PH3. Correct. BiH3 is least stable. Yes. Thermal stability decreases down the group, because as you go on down the group, your covalency, obviously the element is much bigger. So therefore it is easy to release the hydrogen. The stability decreases. So stability of the hydrides decreases in the order. Yes, it is correct. Option this is correct. Then reducing ability of the hydrides increases in the order. This is also right. Yes, because see, imagine NH3 is this and Bi is big one, BiH3 is like this. Okay, obviously here hydrogen will be released easily, right? And here to release hydrogen is a little tough, right? So whichever easily releases H plus ions is a better acid, and that is a better reducing agent, right? Reducing ability matlab this compound should be able to behave as a reducing agent. So reducing agent gives you the H plus ions, hydrogen donor hai wo, right? So it gives H plus ions easily. So BiH3 is better. So option 2 is correct. Next, among the hydrides, NH3 is stronger reducing agent. Na baba na. BiH3 is a stronger reducing agent because BiH3 will be able to release hydrogen more easily. Next, basicity of the hydrides increases. Na acidity BiH3 में है तो basic order क्या बनेगा? उसका उल्टा order बन जाएगा. ये नहीं, इसका बस उल्टा order कर दो, then that becomes your basicity of the hydrides increases. Hydrides वाला order बन जाएगा. So A and B are only right. A and B only are right. Next. Which of the following compounds will readily react with dilute NaOH? That's what is asked to us. You have phenol with अच्छा, not phenol, C2H5. One second, let me just draw again. Yeah. Which of the following compounds will readily react with NaOH? NaOH के साथ C6H5 CH2OH. Okay. C6H5, this is CH2 with OH. Will that react? Or C2H5 will react, or this, phenol. Phenol readily reacts with dilute NaOH, isn't it? Phenol is the one, you can see this here. Okay, will give us what? Say H plus जाके OH पे बैठेगा, water molecule बन जाएगा, minus water कर लेती हूँ मैं, and then you have this with O minus and Na plus, right? So therefore, definitely it is a stronger acid than water also, right? So it will react with dilute NaOH for sure, C6H5OH, which is phenol. नेक्स्ट, करेक्ट स्टेबिलिटी ऑर्डर ऑफ द कार्बोकैटायन. कार्बोकैटायन का स्टेबिलिटी ऑर्डर कहाँ से करेंगे हम? सो जस्ट चेकअप विथ ऑल दीज थिंग्स विथ हाइपर कॉन्जुगेशन. चेक करो बच्चे. सी, यू कैन सी सी विथ CH3, CH3, CH3 एंड पॉजिटिव चार्ज. सी, पॉजिटिव चार्ज को मिटाना है, so the rest of the carbon should be able to help it by releasing the hydrogens from there, so that carbon पे negative बन जाएगा and that negative वाला जो है charge will be put as a bond. तो double bond बनने का scope है यहाँ पे, right? Which means more stability आने का chance है. तो यहाँ पे 3, 3 and 3, you have totally 9 alpha hydrogens. It's a, tertiary carbon has got 9 alpha hydrogens, which is correct, and then secondary, then primary. So option C, I can see this. See, CH3, twice CH and then CH3 and then CH3 plus, right? So this is 3 degree, then 2 degree, then 1 degree, and this is then CH3 plus, right? Correct stability of the carbocation always looks for stability. Bagal wale carbon pe, you should have those hydrogens which are nothing but your alpha hydrogens. More the alpha hydrogens you have, more the stability you will see. Next, 114. Qualitative test for identification of the presence of phosphorus in the compound is heated with an oxidizing agent, which is further treated with nitric acid and ammonium molybdate. Okay. The colored precipitate obtained is presence qualitative test for this. Okay, I can see the options as phosphorus के साथ all these things. So definitely my option 4 is eliminated out of these things. Then molybdenum oxide compound is heated with an oxidizing agent which is further treated. With an oxidizing agent which is further treated with नाइट्रिक एसिड के साथ. ओके, नाइट्रिक एसिड में से H प्लम बनेगा एंड अमोनियम मॉलिब्डेट ऑल्सो. अमोनियम मॉलिब्डेट पहले मैं लिख लूंगी, NH4 प्लस एंड देन MOO4 minus 2. सो molybdate, this is what is molybdate, and then ये बन जाएगा आपका NH4 twice, MOO4 बन जाएगा. सो इसके साथ क्या होना चाहिए? It has to be your phosphate ions. PO4 minus 3 होना चाहिए definitely. Then PO4 minus 3 में NH3, NH4 positive 1. This will be your answer with 12 times your MOO3. यस बच्चा, दिस वुड बी योर थिंग. अमोनियम के साथ तो अमोनियम आयन्स ही बनते हैं. सो NH4 थ्राइस PO4 के साथ मोलिब्डेट आयन्स बन जाएंगे MOO3. सो ऑप्शन 3, ऑप्शन C इज योर आंसर देयर. Next, how many of them have D2sp3 hybridizations? D2sp3 hybridizations, just go on with, putting your things here. How much is this coordination number? Here is 6, here is also 6, 6. All of these here are 6 here. You just have to write those elements, Nana. In the presence of ligand क्या बन रहा है, everything you just show that, we have done that ना. भाई आ रहा है तो क्या होगा, right? One second, my pen is stuck. One second. कोबाल्ट पे देखते हैं, कोबाल्ट विल बी +3 हियर, ओके, वुड बी माई 3d6 सो 3d6, 4s पे 0, ओके, 1 2 3 4 5, yeah, 4s पे 0 we have, and we have ammonia coming up, 3d6 पहले 1 2 3 4 5 and 6, and ammonia is your strong ligand definitely, so your last electrons would drop down here, and which means your new thing, 1 2 3 4 5, yeah, which will be looking up like this, right? 1 2 here, 3 4 5 6 here. You have this empty, D2 emptied down, S any way you want, S you want, and then we have six boxes we want, right? Because ammonia is a monodentate ligand coming up with one pair of one box each. You have six boxes you want. So three boxes already there. And then 4p. This is 4s and 4p mein to three boxes. So D2sp3. So cobalt with ammonia. Okay, six times. That is your D2sp3. And platinum also check karo. Platinum with Cl6. Platinum is, going up with platinum +4, right? Because Cl -6 है, -6 turns to the right side. Platinum X लेते हैं, Cl is -1, 6 times you have -6 is equal to -2, X is equal to 4. 6 -2, 4 आ रहा है, X equals to 4. Platinum +4 बनेगा. Okay, then it will be 5d6 बनेगा. Go with the configuration, बच्चा. Remember those numbers and all. Right, so it will be 5d6 बनेगा. 5d6 मतलब क्या, 1 2 3 4, right? 1 2 3 4 5 and 6. अमोनिया आ रहा है तो पीछे जाना ही है. 4s पे 0, सेम अगेन, पीछे जाना है तो ये दोनों वापस पीछे आ जाएंगे. यू हैव टू थिंग्स एम्प्टीड डाउन देयर, so D2sp3 again there coming up. So definitely option here you have, how many of them have, yeah, this also will have, and yeah, only two of them will have this. SF6 पे नहीं. Fluorine is a weak ligand. Fluorine weak ligand है, तो weak ligands they don't come back here like this, right? Next, moving on. How can we convert electrochemical? Oh, sorry, one second. Mm, yeah, chlorine with 6. Yes, correct only. Yes. Fluorine is weak ligands, they will not come back. Yes. Next, move on. How can we convert electrochemical cells into electrolytic cells? Electrochemical cells to electrolytic cells. Electrochemical, which means your chemical energy to electrical energy. Electrolytic cells is electrical energy to chemical energy. Then, by changing the electrodes, no. Reversing the moments, no. Applying opposite, no. By applying opposite higher potential, that will be the answer. Applying opposite higher potentials, you would be able to convert this. Remember that option D. Which structure of protein is intact after coagulation of egg white on boiling? So it is primary protein. Bacha, denaturation of protein will cause the structural change in secondary and tertiary proteins, but the primary protein में intact रहेगा. Coagulation के बाद primary protein intact. Primary intact. Remember this word, primary intact. There is no change observed there. Next, 118. While moving from nitrogen to phosphorus, covalent radius increases significantly, but from AS to bismuth, only a small increase is observed. Yes or no? Tell me, check out your series this. Yes, it is right. Nitrogen to phosphorus radius increases significantly, but this because of your poor shielding effect. Your from antimony to bismuth, only a small increase is observed because of the poor shielding effect. Reason क्या बोला है यहाँ पे? For a particular oxidation state, covalent radii and the ionic radii generally radii increases down the group, that they say. It is not, reason is correct only, but not the correct explanation. Correct explanation kya hai? Correct explanation is your poor shielding effect. Poor shielding effect is my correct explanation, not this. Next, moving on. 119, last two questions. Let's finish it up. Yeah, concentrated HNO3 in the presence of concentrated sulfuric acid will give you nitration, and nitration will impart your nitro group in the product. And NaNO2 and HCl and all nitro group A, and you have SnClC second, this is the option A, and then after this you will get SnCl2 and HCl, or Sn and HCl will give your reduction पे oxygen जाएगा, hydrogen आ जाएगा, NH2 बनेगा. So option A thing is NH2 there, aniline. Aniline पे NaNO2 and HCl will definitely give you N2Cl. N2Cl will be definitely your diazo salt. Diazo salt. Option A, hydroxyazobenzene, diazo salt. P, hydroxyazobenzene. Next, identify the incorrect statement regarding the primary and all. Incorrect statement देखना है regarding the primary standards of trimeric analysis. Okay, that's fine. Trimeric analysis and all right now not there for you. That's okay. You can leave that. No problem. So that is how it is. So we have finished 120 questions today. Yeah, 60 questions we have done today. So I want you to go through all these questions. In case any doubts you have, please come back to me on that. All right. And please write your short notes so that before your exams, before your first attempt, you should be able to do so many questions, 300 questions. I will be making you do these questions. We will do 300 questions in the next coming up 3 days. Then I will be going up with your 2023 chapters tests as well, to 2023 as well. Okay, so that is how we can go on doing so many questions at a time, everything together, all the 2 years of chemistry, organic, inorganic, and your physical, everything put together. That will give you a good idea of how to go on with your questions. In case, because definitely your questions are not repeated in your JEE, but such kind of questions, if you come up across these questions, you should not leave them. Just bring it on those marks. All right. So that is how it is for today. Bye bye. Signing off. This is Harita Kasturi from PACE Hyderabad. Bye. See you. Happy learning.